بسم الله الرحمن الرحيم. Example على how to find SI in Gauss-Seidel load flow method. وقصدي ب SI هي SI اللي تظهر في المعادلة اللي هي بسط، هذا البسط SI. طبعا إذا عرفنا SI نقدر نعرف conjugate ونقدر نعرف قيمتها of iteration K. حكينا last time إنه SI أو SI conjugate of iteration K is fixed value except one case, when bus I is a generator bus. In this case, to find SI, you have to find the QI using the expression we mentioned in the last video or lecture. This example is how to find the value or the expression of SI or SI conjugate of iteration K. Usually we need to find SI value for all buses except the reference bus. Example, this is a 4-bus system. We have bus 1, it's a load bus. S demand at this bus is 8 plus J6. All values are in per unit. Bus number 2 is a reference bus, or swing bus, or slack bus. It has a generator. Because it is a generator bus, voltage magnitude at bus number 2 is known. Let's assume given as 1.05 per unit. والangle at bus رقم 2 is 0, which means it's a reference bus. And S demand at bus 2 equals to 2 plus J1. بس رقم 3, it's a load bus but has reactive power generation at bus 3 using this capacitor. So this capacitor produces reactive power. Bus number 4 is a generator bus. Because it is a generator bus, BG4 is given, and because it's a generator bus, V4 magnitude is given, it's 1.1, and S demand at bus 4 is given by 4 plus J3. As you know, when we solve for load flow, we accept or exclude the reference bus from our calculations. So we have to write equation for bus 1, bus 3, and bus 4. But we don't need to use equation for bus 2 because this is the reference bus. For this bus, the admittance matrix is 4 by 4. Let's assume given by symbols Y11, Y12, Y13, and so on. Let's see how to write Gauss-Seidel equation for each bus. For bus 1 is a load bus. So SI will be fixed. Bus number 2, also a load bus. So SI at bus number 3 is fixed number. But bus number 4 is a generator bus, so S4 is not fixed. For bus 1, this is bus number 1. It has a demand of 8 plus J6. S generated at this bus is 0 plus J0. So we can find the net injected complex power at this bus as SG1 minus S demand 1, 0 plus J0, minus, this is the demand at bus 1. So S1 equals to minus 8 minus J6, which is a fixed number. So if it's a fixed number, that means SI of iteration K is a fixed number. So S1 of iteration K conjugate is minus 8 plus J6, which is a fixed number, does not change with iteration. So you have to calculate this value once. Then نقدر نستخدم هاي الإكويجن V1 of iteration K plus 1 تساوي 1 على Y 1 1 minus this fixed number. This will change with iteration, and these are the admittances multiplied by voltages. It's 1 1 2 because it's bus 1 with respect to bus 2 1 1 2, bus 1 with bus 3 Y1 3, bus 1 with respect to bus 4 1 Y1 4 V4. But notice that because bus number 2 is the reference bus, V2 is a fixed number, which equals to voltage magnitude 1.05, and the angle is 0 because it's a reference bus. For bus number 3, this is a load bus, the same as here, with one exception that there is a capacitor at bus number 3 which produces reactive power. This is bus number 3. This is the reactive power produced from capacitor, which is J plus 3, and S demand 3 is 6 plus J 5. SG3, this is S demand 3. So net injected complex power at bus رقم 3 is S generated at 3 minus S demanded at 3. 0 plus J3 minus, this is the demand at bus 3, minus 6 minus J2. This is a fixed number. S3 conjugate is minus 6 plus J2. Fixed, does not change with iterations. So S3 conjugate with iteration K is a fixed number. If you put this value in this equation for bus number 3, V3 of iteration K plus 1 تساوي 1 على Y 33. This is a fixed number, does not vary with iteration. This is V3 of iteration K. And this is because this is for bus system, should be 3 terms. Bus 3 with bus number 1, bus 3 with bus number 2, bus 3 with number 4. But we accept, we exclude bus number 3 with itself. So there is no Y33 here. Again, as before, because bus number 2 is a reference bus, voltage at bus number 2, the complex value, is known and fixed, does not change with iteration. It's 1.05 with angle 0. Let's see for bus number 4. Bus number 4, it has a generator and a load. BG4 is a 3, and voltage magnitude at bus 4 is 1.1. So this is bus number 4 alone. This bus is a generator bus. So we will notice that Q4 is not known, but we have to calculate Q4 using this relation minus imaginary part of V4 conjugate multiplied by I4. و I4 إذا أحطها على شكل summation تظهر بهذا الشكل، وإذا أفك هذا السميشن it's Y41 V1 plus Y42 V2 plus Y43 V3 Y44 V4. 4 terms because this system is 4-bus system. Let's go back to bus number 4. At this bus, SG4 is 3, but QG4 is not known. So this is SG at bus number 4 is 3 plus JQG at generator 4, but S demand at bus 4 is 4 plus J3. So when we find complex power, net injected complex power at bus 4, it's generated complex power minus S demanded power. So it is 3 plus JQG4 that we don't know. This is not known. This is known. And S demand at bus 4 is known. So when you subtract the two terms or the two brackets, you will get 3 minus 4 is minus 1. QG4 is not known, unknown, minus 3 known. So the net result is unknown. So we will call it Q4. In this case, S4 conjugate is minus 1 minus JQ4. If we put the counter K, minus 1 minus JQ4 of K. So this is known, but this is not known. So how to calculate Q4 using this relation, using this equation. So when a bus is a generator bus, in every iteration you have to calculate the reactive power. This is bus 4, Q4 of iteration K. So Q4 of K is not fixed. Therefore, S4 of conjugate of K is not known. Minus 1 minus JQ4 not fixed. But remember, this is very important notice, that bus 4 is a generator bus. Because it is a generator bus, its voltage is fixed. Voltage magnitude, I mean, is fixed at V4 magnitude يساوي 1.1. وأنا أعمل iterations إذا تغير الماجنتيود of V4 لازم أعيد وأثبته at 1.1 أعمل له correction. Therefore, after each iteration of V4, you must correct the magnitude of V4 to be 1.1. Example, if after the first iteration you obtained V4 of iteration 1 equals 1.08 والزاوية minus 3.1, then you have to replace ال 1.01 بواحد وواحد بالعشرة. This is called correction. If after the second iteration عملنا الiteration الثانية إذا again you obtain different magnitude, for example V4 of iteration 2 1.095, this is the new angle, then you have to correct the magnitude, and so you have to replace this number by 1.1. So إذا تعوضوا معادلة S4 بمعادلة Gauss-Seidel الأصلية, you will obtain V4 of iteration K 1 على y 4 minus 1 minus jq4 of k، وباقي المعادلة 3 terms، بس 4 مع بس 1، بس 4 مع 2، بس 4 مع 3. وأجين this is a fixed value does not vary with iteration even though احنا نحط فوقيها iteration k. لا صار عندنا 3 buses، إذا استثنينا الرفرنس تبقى عندي 3 buses، لكل بس في عندي equation. البس الأولاني it was a load bus so this is fixed value. البس الثالث كان load bus في reactive power capacitor، برضو هاي fixed value. again شرحنا عن هذول. البس الرابع اللي هو كان في جنريتر هو اللي سبب لنا المعضلة لإيجاد الرياكتيف باور. الريال باور بارت اوف اس 4 ما في مشكلة، كان فيكست، لكن كيو 4 هاو تو فايند كيو 4 زي ما حكيت قبل شوي انه you have to use this equation. اذا بكل iteration لازم تعمل هاي الحسبة. لا اذكركم بالصف اخذنا ان اذا لقيت V1 من المعادلة الاولانية updated value، ليش ما استفيد منها بالمعادلة النكست equation عشان اقلل عدد الايتريشنز؟ بدل ما احط هاي كي احطها كي بلس 1. هلا صار معروف معي V1 و V3 صاروا الابديتد فاليوز لهم معروفات، ليش ما استفيد منهم باللاست ايكويجن؟ فاحطهم K V1 K بلس 1 و V3 of K بلس 1. How to find the Q4 of iteration K using this relation. Q4 لما اوصل لعندي Q4 minus imaginary part برضو استفيد من الابديتد فاليوز ل V1 و V3، فنحطهم of K بلس 1. لو خليناهم of K ما في مشكلة، لكن ياخذ iterations أكثر عشان نوصل للحل. هلا how to find أو to assume initial guess. إذا كان non-generator buses I mean load buses the best way is to assume initial values لهم الماجنتيود 1 والزاوية 0. always احنا نفترض initial guess للانجلز 0. اذا كان non generator بس نفترض له الانيشال guess 1 و1. بينما بس نمبر 4 لانه generator بس وقايل لي انه الفولتية تبعته 1.1، the best estimate is to assume الفولتج اللي given معك للبس نمبر 4. اذكركم انه بس نمبر 4 كان معطيني الفولتج له 1.1، ف this is the best estimate للماجنتيود، بينما الانجل تساوي 0. إذا we assume this value because it is a generator bus whose voltage magnitude is known and fixed at V4 magnitude تساوي 1.1. الله يعطيكم العافية، شكرا جزيلا، السلام عليكم.